Hi, welcome to stoichiometry mole to mass ratios. Avogadro's number and the mole. Avogadro's number again is 6.02 times 10 to the 23rd. That is 602 with 21 zeros behind it. That's a lot of zeros. So what is a mole? Well, it's a counting unit, just like dozen. It is the number of represented particles contained in 1 mole of a substance. It is similar to a dozen, again, except instead of 12, it's 602 billion trillion, or 6.02 times 10 to the 23rd. This is Avogadro's number, named after Amedeo Avogadro, who studied the quantities of gases and discovered that no matter what the gas was, there were the same number of molecules present. So, how big is a unit of a mole? Well, if you had Avogadro's number of unpopped popcorn kernels and spread them across the United States, it would cover the United States of America 9 miles deep in popcorn. So, 1 mole of carbon is 6.02 times 10 to the 23rd atoms of carbon. 1 mole of H2O is 6.02 times 10 to the 23rd molecules of water. 1 mole of NaCl is 6.02 times 10 to the 23rd formula units of NaCl. But more specifically, it's also 6.02 times 10 to the 23rd sodium ions and chlorine ions. Let's look at some gram formula masses. Gram formula mass is the molar mass, or the mass in grams of 1 mole. It is the numeric value of the average atomic masses from the periodic table. So 1 mole of carbon is 12.01 grams. 1 mole of magnesium is 24.31 grams. 1 mole of copper is 63.55 grams. So a molecular mass is also called the molecular weight, is the same numeric value as 1 mole of molecules. It's the beauty of Avogadro's number. The formula mass, or formula weight, is the same as the molecular mass, or the molecular weight. It's the same numerical value. So why are there so many names for the same thing? Well, all of them are the same number, just different units. Same number, just different units. Because you'll also hear it talked about as the AMU, or the average atomic mass, or you'll hear it as the AMU, the atomic mass unit. You're going to hear all kinds of things, all talking about the same thing. So as an example of molar mass, what would 1 mole of bromine be? That would be 79.9 grams per mole. And 1 mole of tin would be 118.76 grams per mole. Stoichiometry, remember, involves the mass relationships between reactants and products and the balanced chemical equations. An equation gives the relative number of moles of reactants and products. So you're going to solve problems using ratios from balanced chemical equations. So if you had this balanced chemical equation of H2 plus O2 makes H2O, possible mole ratios could be 2 hydrogen to 1 oxygen, 2 hydrogen to 2 water, 1 oxygen to 2 hydrogen, and so forth. Any combination thereof. So in reaction stoichiometry, mole to mass and mass to mole, you are either going to be given the mole and find the mass, or you're going to be given the mass and you have to find the moles. So let's do that. Remember your action plan or your steps. Step 1, start with dimensional analysis of what you are given, what you know. Then you make your units convert, filling in the corresponding numbers to go with those units and cancel the units that you want to convert. Multiply across the top and divide across the bottom to get the final answer. So here's an example. You start with 15 grams of N2O4. Notice the equation is already balanced. 1 N2 plus 2O2 makes 1 N2O4. Start with what you're given. Put units in to make them cancel. So grams of N2O4 become grams of N2O4 to the moles of N2O4. Moles of N2O4 become the moles of O2. Make the units transfer. Then fill in the corresponding numbers. We find the molar mass of N2O4 is 91.98 grams per mole. We also find from the balanced chemical equation that 2 moles of O2 go with 1 mole of N2O4. Finally, then we do the math. Multiply across the top, divide across the bottom, and we get a final answer of 0.33 mole of O2 were required to produce 15 grams of N2O4. Thanks for watching.